Hello friends, this is Jay Prakash and I am back with the final video of LVM series. So today we will see how to configure LVM and extend it and remove it on a running system. So previously we have already discussed what is LVM, how to use it and how you can configure LVM volumes during the installation. So let's start. So running on a running system, when you want to configure a LVM, you just need to see how many hard drives or disk partitions are there where you can create it. You have a free space. So in this machine I have one existing hard drive where the automatic partition scheme was chosen during the installation. After that I have added two more hard drives. Let's see how to see it. There is a command lsscsi lsscsi. So here you can see how many hard drives you have in your system. One is SDA, another is SDB, and third one is SDC. So SDA is already being used by my operating system. I have added two more. We are going to configure LVM on these two drives. Let's start with fdisk, fdisk space -l. If you do this, it shows you what are the partitions are configured on your physical drives. So at the bottom you can see there is a drive SDA, it's 21.5 GB, and there are two partitions are configured, SDA1, and you see the system is Linux, so it's a standard partition. It is your boot volume. Second one is SDA2, it's Linux and tagged with LVM, so it's a physical volume, and inside that physical volume we have the system is configured logical volumes. These two logical volumes are mentioned here. One is 18.2 GB, another is somewhere around 2 GB. Let's move upside. Here you can see one disk /dev/sdb, it's around 10 GB. There is no partition. Apart from that, there is one more disk, it's SDC, it's 10.7, there is no partition. So first we need to create a raw partition on both of the drives. See how we can create it. fdisk space /dev/sdb, enter. You need to type P and press enter to see the partition table. Currently it is empty, there is no partition. To create a partition, type new n for new and press enter. It will ask you it should be primary or extended. By default it is P, it means primary. Press enter. Partition number by default 1, enter. Start sector default size, enter. End sector default size, enter. Now again type P, press enter. Now you can see there is a partition created called SDB1 on the drive. It has taken all the space and the system is Linux, but still it is not tagged with LVM. If you don't tag it with LVM, it's okay, but it is recommended to identify which one is your LVM physical volume. You should tag it with LVM. So to tag it with LVM, type T, press enter. So it will ask the number of the LVM. If you don't know, by default it is 8E. If you don't know, you can press L and enter. Here this is the list, the type of partitions this Linux support, but here we need only LVM. So Linux LVM type is 8E. We should type 8E, press enter. Again P, enter. Now the partition is tagged with LVM. So it now, if anybody see it, it is clear that this partition is going to be used for LVM only. Type W for save, press enter. Now it's out. To see the partition is created or not, fdisk-l space /dev/sdb, enter. So now you can see the partition is created and it is saved. Same thing we repeat with the SDC, fdisk space /dev/sdc. type P, there is no partition, create new, it's enter, 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 enter. P, partition is created, tag it with LVM, T 8E, enter, again P, partition is created, type W and exit. So now we have created raw partitions. Let's move and create physical volume. So we'll go with disk SDB only, and later on we will expand it using SDC. So let's create a physical volume on SDB. So the partition we created is SDB1. So command is pv create. It will convert the raw partition into physical volume. pv create /dev /sdb1. So this is the raw partition we are going to use for it. So it says physical volume SDB1 successfully created. So it has been created, but we'll see is it created or not. So the command is pvc or pv display, pvs /dev /sdb1 is created. It's LVM2. The size is 10 GB and free size of this physical volume is 10 GB. So it's totally free. It is not being used by any volume group. If you see the VG, the space is empty because we have not yet tagged this particular physical volume with any volume group. The existing hard drive already have a volume group named CentOS. Will not use it. Now let's create a volume group. VG create. Name of the volume group is test. Now the physical volume which you want to use the for this volume group /dev /sdb1. Enter. It says volume group test successfully created. Let's check it is created or not. VG name test is created. Physical volume 1, it is attached. Logical volume, there is no logical volume inside this volume group. Size of this volume group is 10 GB and entire 10 GB is free. Now we'll create logical volume inside this volume group. LV create -L, it is for capital L is for size, defining the size. We'll give the size like 5G. So I am going to create a 5 GB volume inside this volume group. Now we need to define the name of the logical volume, -N for name. The name is TESTLV. It's test logical volume. Now you need to put the name of volume group. Volume group name is test. Just press enter. So this LV was already created previously for testing purpose. That's the reason it is giving this warning, but you won't see this warning. You will see only this logical volume test LV created. Fine. Now check the logical volume is created or not. LVS, enter. You can see test LV is there. The volume group name is test and the size of the logical volume is 5 GB. Here now we have 5 GB free on the test volume group and we have 10 GB more free on another disk. So now I will show you how to mount it and use it, and then once it is being used how you can extend it. So before going to extend the logical volume, we'll see VGS. So currently the volume group size is 10 GB but only 5 GB is free. So let's extend it. LV extend -L is now the size which I going to add here. I should use it plus sign, it means you are going to add this size. Let's suppose 3G, like 3 GB I am going to add more. Now I don't need to define, I need to just give the path of the logical volume slash dev slash MAPPER mapper. It is test hyphen test LV. This is the actual path of the logical volume which was created earlier. Press enter. What it will say, logical volume test successfully resized. If you see LVS, earlier it was 5 GB, now it is 8 GB. So this is how you can extend your logical volume when it was not in use. Now let's format it and use it, and then we'll increase it. So I'll do mkfs.ext4. I am going to format it with ext4 file system slash dev slash mapper test hyphen test lv. So it's formatted. Now I will mount it to slash mnt mount slash dev slash mapper test hyphen test lv slash mnt. It is mounted. Let's check it. df hyphen h. So here you can see, so my test lv logical volume is mounted to slash mnt folder. I go to this slash mnt and the size is 7.8 GB. Just remember it because I will increase it and you will need this size at that time. Slash mnt ll. There is no file and folder. Let me create touch JAIIT workshop. See, there is a file now inside it. Now we'll extend it. LV extend hyphen L space plus 2G, because we have that space only in this particular logical volume, space slash dev slash mapper, enter. Insufficient free space, so let me go back. It's 1.5 G. Press enter. So logical volume test successfully resized. Now check the size LVS. Now the size is 9.5 G. Earlier it was 8 G. My logical volume is currently mounted and it is being used because I am already into MNT folder. Now df-h, but logical volume is resized, but here the mounted partition size is still the 7.8 G. So now we have to format the additional space which we added recently. So you need to resize to fs slash dev slash mapper slash test hyphen test lv, then press enter. So test lv is now, the block size has been changed. Now if you go see df space hyphen h, dev mapper test lv size is now 0.3 GB. Your logical volume is now extended online while sitting inside this folder. So this is how it works. Now I am going to add another physical volume to extend the volume group. So we have already created a raw partition on SDC drive. Let's convert it into physical volume. PV create slash dev slash SDC1. It is successfully. Now check it, PVS. Now you can see SDC is also available. Size is 10 GB but not in any volume group. Now instead of creating another volume group, extend the volume group. VG extend volume group name test and the physical volume which you are going to add here, /dev/hdc1, enter. The volume group test successfully extended. Let's check it. VGS test volume group now has two physical volumes. Only one logical volume is created and the size of volume group is now almost 20 GB, and it has almost 10 GB free because we have recently added a new disk. Now what we will do, we will extend the existing test LV by more 5 GB and create a new LV here. LV extend -L space plus 5G /dev/mapper test LV. Press enter. Oh sorry, there's a space in between. Yeah, so logical volume test LV successfully resized. Let's check it. LVS. So test LV new size is 14.5 GB. It's almost 15 GB, right? Let's resize the, let's check -H. Size is still less. Let's resize to FS mapper test LV. Block size has changed. Let's check it. DF-H. The partition size is now 15 GB. So this is how you can add one more drive or multiple drives and extend your existing logical volumes. So in the background, the LVM technology manage how the data will be written on which disk. So we'll create one more logical volume. LV create -L 4G -N test LV2 N. So here -L for size, 4G the size of the logical volume, -N for name. Test LV2 is the logical volume name, test is the volume group name. Press enter. So volume, sorry, TEST. So test LV2 is created. Let's go and check LVS. Test LV2 is there. The volume group is test. The size is 4 GB. Fine.